Learning Objective 4.1a wants us to solve and graph inequalities with a variable on one side. So this first example, 5 is greater than 3x. We want to get x by itself. So first thing I want to do is to get rid of the multiplying by 3 and divide by 3. So that's going to say 5/3 is greater than x. Now it's actually easier to read these inequality statements once they're solved when x is first. So what you can do is take this whole thing and flip it. If you flip it, it's going to be x, and this flips also to now less than 5/3. So either one of these two formats is correct. This tends to be easier. Now we want to have to graph x is less than 5/3. Now 5/3 in your calculator is approximately 1.67. So let's make the number line, have this be 0, 1, and 2. Now remember, because right here it is a less than with no equal to at 5/3, it's an open circle. So I'm going to do an open circle at 5/3. And from that point, I want all the x's that are less than that. So anything less than is to the left. So for example, I could put 0 into here. 0 is less than 5/3. So again, everything to the left. The next one, negative 5x plus 6 is less than or equal to 21. To get x by itself, we have to move the negative 5 and the 6. Work your way toward the x. So let's get rid of the plus 6 first. To get rid of plus 6, we're going to subtract 6 from both sides. That's going to leave us with negative 5x is less than or equal to 15. To get rid of the timesing by negative 5, we're going to divide both sides by negative 5. Now be careful, when you divide by a negative, you actually have to flip the inequality symbol. So the new inequality is going to be x is greater than or equal to 15 divided by negative 5 is negative 3. So this is the inequality, and we need to graph that. So we need to have negative 3 on the number line. So let's just go ahead and put 0 here, negative 1, negative 2, negative 3. And we know based on the inequality it has the line. So it is x is greater than or equal to. So we're going to put a solid circle at negative 3 and clean color that in. And I want all the x's that are bigger than negative 3. And that's going to be everything to the right. When the variable is written first as an inequality, you can draw the arrow in the same direction as the inequality statement. It will always work that way. So in this case, I know pointing it to the right or the same direction as the greater than or less than symbol is correct. Double check. Does 0 work if I put it in here? 0 is greater than or equal to negative 3, so it is a true statement. 4.1b, we're going to solve and graph inequalities when there's variables on both sides. So in this inequality statement, we can start it one of 4 ways. I'm going to actually choose here to let's move the 8x over to this side. So I'm going to subtract 8x from both sides. Now be careful when you subtract in an inequality, you do not change this inequality statement. Keep that just like it is. It's only dividing and multiplying by a negative. So that's going to leave us with a negative 6x minus 5 is greater than or equal to 1. Now we're going to have to add 5 to both sides. So that's negative 6x is greater than or equal to 6. Now we're going to come in and divide by a negative 6. Dividing by the negative is going to cause this inequality symbol here to flip. So what we're going to have is x is now less than or equal to negative 1. We're going to graph that on the number line. So I'm just going to put 0 here. I'll put 1 and 2. Negative 1 and negative 2 to space it out properly. And because it is a or equal to, I'm going to do a solid circle at the number negative 1. Solid at negative 1. Again, since x is first, I can just draw the arrow in the direction of this inequality. But really when it points to the left, it means less than. So I note the x's that are less than or equal to negative 1. The x's on this side are less than or equal to negative 1, such as negative 2. So let's draw the arrow this direction. Those are all our answers. 4.1c, solve and graph and compound inequalities. This is called an and statement, and it's a compound because there's 2 problems in one. What we're going to do is solve this problem right here at the same time as this side of the problem. What we want to do is get x by itself in the middle. So in order to get its x minus 2, to get rid of minus 2, you're going to add 2. So we're going to add 2 there, and we're going to do it on both sides of the inequality. That's going to leave us with negative 2 plus 2 is 0, less than or equal to x, and then it's less than 3 plus 2 is 5. This is the statement that we have as our final answer, and we're going to graph that. So at the number 0, we're going to put a solid circle. At the number 5, an open circle. So let's just get our number line set up and label it appropriately. Again, at 0 is a solid circle. At 5 is an open circle. And if you notice this, x right here is in between 0 and 5. Well, you want all the x's in between 0 and 5, so all you do is you connect the line here. What that tells me is, for example, the number 2 is a correct answer. Is it true? If I put 2 in here, would that work? Well, think about it this way. This opens up to the larger number. 0 is less than or equal to 2. That's true. Is 2 less than 5? That's also true. So again, everything on this band is the answer. 4.1d, solve and graph or compound inequalities. This is similar to the and compounds, except there's two equations. It's this equation or this one. It's basically just doing two problems in one, and then you graph them on the same number line. So let's go ahead and solve. To get 5x minus 2, to get x by itself, I'm going to add 2 first to both sides. That leaves us with 5x is greater than 7. Now I'm going to divide by 5. So we have x is greater than 7 over 5, and this is one of the answers. The other one, we have negative 3x plus 1. We need to move the plus 1 and the minus 3. To get rid of plus 1 first, because it's furthest out, we're going to come on here and subtract 1 from both sides. That's negative 3x is greater than negative 7. Divide by a negative 3. When you divide by a negative, don't forget the inequality symbol switches. Here a negative divided by a negative becomes a positive, so it's 7/3. Now what we're going to graph is you might want to first figure out what decimals these are. So if you put them into your calculator, notice that 7/5 is the same as 1.4 as a decimal, and then 7 divided by 3 is going to be about 2.33. So on the number line, why don't we put 0 here, 1, 2, 3, 4, and so forth. First graph this one, it is going to be an open circle at approximately 1.4. So at 1.4 is about right here, open circle. And let's just complete the problem. Here it says I want the x's greater than that. So I'm going to go greater than, I'm going to go in the direction. It's going to be this way. On this one here, what they want is they want the x's that are less than the 2.33. So 2.33 is an open circle, and that's going to be about right here. And I want them less than, so it's going to go in this direction. So that is what the graph looks like. You're going to notice on the OR compounds, you're going to see the arrows go in two opposite directions. This is what the ORs always look like. These two arrows will never go in the same direction, always opposite. In a similar fashion, back at the AND compounds here on this previous problems, AND problems will always be one complete line segment. You will never see the opposing arrows on the ANDs. 4.2a is check solutions of inequalities. Check whether the ordered pair is a solution. Does -1, -2 work for this inequality? Well, this ordered pair just represents x and y, so all you have to do is plug those in and see if this is a true statement right here. So let's do 3 times a -1 minus 2 times a -2. We're going to see if it is less than -1. This becomes -3. This becomes +4. Is it less than -1? This actually will simplify to 1 is less than -1. Now the question, is 1 less than -1? This is false. It's not true. Therefore, no, it's not a solution. Would be the appropriate answer. 4.2b wants us to graph one variable inequalities. So it would be something like y is greater than 3. This is basically going to be all horizontal and vertical lines. So the first thing you want to do is just graph it as if it were a regular equation, y equals 3. Remember, to graph that, you would go to the y-axis at 3, and in this case, we're going to go against the y-axis. We would draw a line horizontally. Now be careful before you draw a solid line. Look back at here. Because there's no equal to, it's actually a dotted line. So you would make sure you have a dotted line that looks like this. Now the last step you have to do is decide, should you shade on this side of the line or should you shade upward on this side? Easiest way to do it is to pick a point on the side. The ordered pair 0, 0 is available. So let's put the ordered pair 0, 0 into this equation. All this equation needs is the number for y. Well, the value for y here is 0, so I'm going to put that 0 into here. So is 0 greater than 3? Is that a true statement? No. That's false. 0 is not greater than 3, which means this is the wrong side to shade on. What you would then do is by default shade on this side. You can also do a shortcut to this shading if you don't want to pick the point here like we did. If you think about it logically, this says y is greater than 3. You want all the y's that are greater than 3. Well, on the graph paper, these y values here are higher than 3. These are lower than 3. So you actually would shade for the higher values of y, and that will work every time. 4.2c wants us to graph two variable inequalities. So here we have x and y. So now we're going to get a line that has a tilt to it. The easiest way to graph these is to set them up in y equals mx plus b format. So remember, to do that, we need to get y by itself. So what I would do is get y by itself, which means you have to move the 6x and the minus 2 away from the y. Work your way towards the y, so do the 6x first. So subtract 6x from both sides. It's going to leave you with negative 2y is greater than, and do negative 6x and then plus 8. To get rid of the negative 2 times y, divide everything by negative 2. But be careful, dividing by negative just caused me to change the inequality symbol to less than. Negative 6 divided by negative 2 is 3 and x. Positive 8 divided by negative 2 is a negative 4. Now based on this, I can identify that the slope is 3. I like slope as rise over run, so I'm just going to put it over 1 to see its run. And then the y-intercept is negative 4. So to graph it, I'm going to go to the y-intercept at negative 4 first, plot a point. From this particular point, I'm going to move the slope, rise over run. I'm going to rise 3 and go to the right 1. So from here, rise 3, right 1. Now before I connect the dots, I look back at this and notice there's no equals to. This here is another dotted line. So you have to do the dotted line. Now the last step is to figure out, do we shade on this side of the line or this side? Again, if the ordered pair 0, 0 is available, I like to try it out. So I'm going to take the ordered pair 0, 0 and I'm going to put it back into this equation here. I could put it in the original one too. It's going to work either way. If I do that, this would say 0 is less than 3 times 0 minus 4. That would say 0 is less than negative 4. 0 is not less than negative 4. This is false, which means this is the incorrect side. So here I would shade downward on this side. And that's your final answer. 4.3a wants us to check the solution of an inequality system. So check whether the ordered pair is a solution to the system. Does 2, negative 8 work in this entire system? All you need to do with that is to put in the ordered pair into both. It has to work in this one and this one for it to be true. So let's just do the top one first. 2 is the x, negative 8 is the y. So make sure you put it in the right spot. Negative 8 goes here. So it'll be negative 2 times negative 8. Is it less than 4 times 2 minus 1? This would be 16, which is less than 8 minus 1. It says, is 16 less than 7? 16 is not less than 7. Again, this is false. Since that's false, I can stop already and say no, it is not a solution to it. Typically, you wouldn't then check the second one unless the first one was correct. Let's check the second one though, just in case the first one had been right. I would put negative 8 here, and I would do negative 3 times 2 plus 4. This would be negative 8 is greater than or equal to. This actually simplifies to negative 2. This one here also is a false statement, so that's not true, therefore confirming that this is not a solution to this system. Learning Objective 4.3b wants us to graph a system of inequalities. All we're going to do is take all 3 of these inequalities and graph them on the exact same graph paper and only shade where all 3 of them overlap. So let's start with this bottom one first. X is greater than or equal to 4. This is actually going to be a vertical line, so go to x at 4 and be careful. Again, it doesn't go with the x-axis, it goes against it, so it's vertical. And it has an equal to, so it's a solid line there. So sketch your solid line. This says I want all the x's greater than 4. The x's that are greater than 4 are to the right, so I'm actually going to shade over to this region. I'm going to do the top one next because it's already in y equals mx plus b format. Here m is 3. Again, if I want to make it a fraction, I can put any whole number fraction by putting it over 1. Here the b is negative 6. So I'm going to go down to negative 6 and plot a point. From there I'm going to rise 3 and go up 1. Careful here, it does have the equals to, so it is another solid line. So let's sketch that solid line. Now I am going to pick an ordered pair for this one. Let's go ahead and pick the ordered pair 0, 0, which sits here, and test it out. If I put 0, 0 into here, we're going to get 0 is less than or equal to 3 times 0 minus 6, which would say 0 is less than or equal to negative 6. 0 is not less than that, so I do not shade on this side of the blue. I shade on this side. Don't shade in this open region because the red one wasn't there. We're actually going to shade right here to where they both overlap. Now let's wrap it up with this last one. We're going to have to take 2x minus 3y is greater than 6 and get it in y equals mx plus b format. Let's subtract 2x. Again, do not change the inequality symbol when you subtract. So negative 2x plus 6. I'm now going to divide by negative 3. When I do that, I do have to change the symbol. It now goes to less than. A negative 2 divided by negative 3 becomes positive. A positive 6 divided by negative 3 is a negative 2. So from here, I have that the slope is 2/3 and the y-intercept is negative 2. So go to the y-intercept at negative 2. From there, I'm going to rise 2, run 3. Be careful on this one. There is no solid line, so this is a dotted graph right here. Now to shade, I am going to piggyback off the 0, 0 ordered pair. And I'm just going to put it right back into here. If I put 0, 0 into here, it'll be 2 times 0 minus 3 times 0. And it says that's greater than 6. That would say 0 is greater than 6. 0 is not greater than 6. That's false. So because of that, we do not shade on this side of the purple line. We would shade on this side. Therefore, the overlapping region where all 3 of them connect is going to be within this final purple shaded region. And that is the answer. 4.4a wants us to solve absolute value equations. Remember, to solve absolute value equations, you have to break it down into 2 equations. So the first equation that we're going to have here is write it without the bars. So 2x plus 3 equals 10. Now the second equation is going to be the 2x plus 3, but we're going to say it equals negative 10. And we basically are just going to do the algebra to solve these. So over here I'm going to subtract 3 from both sides. Leaves with this 2x equals 7. Divide by 2. X is going to be 7/2 or 3.5. On this other side I'm going to subtract 3 again. Be careful, this becomes 2x equals negative 13. I'm going to divide by 2, and I'm going to get that x is equal either negative 13 halves or it's negative 6.5. So there's actually two answers to this problem if you were to put them in for x. If we put 3.5 into here, this whole inside would equal 10. The absolute value of 10 is 10. If we put negative 6.5 for x into here, this whole inside will be negative 10. If you take the absolute value of negative 10, you would get 10. So it's correct, and these are our two final answers. A second problem with that learning objective is this one here. Now before you break this absolute value equation into 2, you must get the absolute value bars by itself. So subtract the 2 first. So you're going to have the absolute value of x minus 4 equals 4. Now this is the equation you break into 2. The first equation would be x minus 4 equals 4. The second would be x minus 4 equals negative 4. When we solve, we're going to add 4 to both sides. So one answer is going to be 8. This other one, again, I'm going to add 4 to both sides. Negative 4 plus 4 is 0. Which means the two answers we would have, if I put 0 into here, 0 minus negative 4 is negative 4. Absolute value of negative 4 is positive 4, plus 2 would be 6. This one would also work. So these are the two correct answers. 4.5a, solve less than absolute value inequalities. These work very similar to the equations in that you can't solve them until you break them into two inequalities. The first inequality is just what we see, so we're going to write 3x minus 7 is less than 13. There is a second one, it's 3x minus 7. We're going to flip the sign to make it greater than and make this negative 13. We need to solve these two inequalities and then graph them on this number line. So let's start this one. We're going to add 7 and then divide by 3. So if we add 7, we're going to get 3x is less than 20. Divide by 3. We're going to get x is less than approximately 6.6. The next one over here, again, add the 7. We're going to get 3x is greater than negative 6. Divide by 3. X is greater than negative 2. So let's set up the number line to graph this. So I'm going to first graph this one here. I'm going to go x is greater than negative 2. Negative 2 is an open circle, and I go to the right. I'm going to come back to this one and do x is less than about 6.6. Again, this is going to be another open circle at about 6.6, and it goes this way. So what I just noticed is there's one complete answer. It's everything in between here. If this was a multiple choice test, what you would see as the answer is they would combine these two inequalities into one compound inequality. And what it would look like, it would be negative 2 is less than x, which is less than approximately the 6.6. And that would be the appropriate answer because it matches this in-between statement. 4.5b works the same way, but now we're going to solve greater than absolute value inequalities. Let's write the first one just like we see it. Then the second one, we're just going to change it to a negative 10. Because we do that, we must flip the sign. Now let's go ahead and solve this. We're going to minus 5 and then divide by 5. So first subtract 5 from here. Leaves us with 5x is greater than or equal to 5. When you divide by 5, we're just going to get that x is greater than or equal to 1. This other one, same thing, subtract the 5. We're going to get 5x is less than or equal to negative 15. Divide by a positive 5. X is less than or equal to negative 3. What we're going to notice is we're going to have some closed circles. Let's do this one first. So let's label our number line. I'll put negative 3 here, and the rest of the numbers counting up. So x is greater than negative 1, or greater than 1, so let's go to 1, solid circle, greater than is to the right. Here x is less than or equal to negative 3, so solid circle at negative 3, and everything is less than, so it goes this direction. These two inequalities stay separate because you notice in the picture they're two separate inequalities. They don't come together. So this is the final two answers, and that's what the graph should look like. 4.6a wants us to evaluate absolute value functions. All they want us to do is use this function here, do one example with -2 and one with 4. So I'm going to first find f of -2. Let's do absolute value of negative. That becomes a -2 minus 9. Be careful, this negative and negative becomes a positive. So it's absolute value of 2 minus 9. That's going to be the absolute value of -7, which will therefore equal 7. The next one, let's put 4 in there. Absolute value of negative, put in the 4, minus 9. This just says -4 minus 9, which is -13. The absolute value of -13 means to make it positive. The answer is 13. 4.6b wants us to graph absolute value functions. So here they want us to make a table of value and have at least 3 points. So the key here is to make sure you pick enough points, and we know that absolute value makes a V shape. So I have an idea of where this graph is going to land, so I'm going to manipulate my numbers a little bit. I'm going to actually choose the number -4, -2, -1, and 0. I'm going to put each of these values that we see here into the equation and see what we get. So -3, absolute value of -4 plus 2. -4 plus 2 is -2. The absolute value of -2 is +2. +2 times -3 is -6. The next one would be -3 and then -2 plus 2. -2 plus 2 is 0. Absolute value of 0 is 0. This becomes 0 times -3, or 0. Let's put -1. -1 plus 2 is 1. The absolute value of 1 is 1. 1 times -3 is -3. And then let's put in 0. So if you put in 0 plus 2, 0 plus 2 is 2. The absolute value of 2 is 2. 2 times -3 is -6. So if you plot these points, what we're going to get is the -4, -6, and -2, 0, -1, -3, and 0, -6. So you're going to actually see the V shape ends up going something like this. So what we have is a downward facing V shape whose vertex, or the origin that used to be at 0, 0, got shifted over, and this is the correct graph. My advice for you on this is if you're graphing it, if you don't see the V shape, pick other values, maybe smaller than -4 or bigger than 0, so the V shape will actually start, because you may not have hit this actual vertex yet.